What's up, Algebra 2 students? This is lesson 19. Our objective for today is how do you solve value word problems and solve AA triangles. And these are not triangles that have a drinking problem. These are triangles where you know two of the angle measures. Okay, so it's called angle-angle triangles. But let's start with that first one here. It says, how do you solve value word problems? Well, value word problems are problems that the variables have values assigned to them that we kind of already know or that they tell us about. So let's here look at this practice A and see if we can get through that. Florence had 80 nickels and dimes, so 80 coins in total, combined of just nickels and dimes, whose value was $6.50 of each coin. How many of each coin did she have? So I've kind of just picked a variable over here on the right to represent the number of nickels and the number of dimes. So what we're going to do is we're going to set up a couple equations. We know since n is the number of nickels and d is the number of dimes, if I added those two together, it would equal 80, because it says she had 80 nickels and dimes. So I know the equation n plus d should equal to 80. Okay? And this is where the value part comes into it. The value was $6.50. So I know each nickel is worth 5 cents. And I know each dime is worth 10 cents. So we can kind of do this two ways. Either we can say that 5n is equal to the number of nickels, and we'd have to convert this into cents, or we could say 0.05n is the value of n, and just leave the $6.50 in dollars. Personally, I'd rather not deal with decimals, so I'm actually just going to go with this method here, but you could go either method that you want. So I know each nickel, so if I had one nickel in this bunch, that would be worth 5 cents. So I know 5 times n would give me the value of money in nickels. And likewise, if I had 10 times d, that would tell me the value of my dimes, right? If I had 10 dimes and each one's worth 10 cents, I'd have 100 cents, which would be equal to $1. Okay? And so then this is going to equal to 650. Notice I converted this dollars into cents. Okay. So now I have a system of equations. And you can, with this, go either way. Solve by substitution or solve by elimination. For this one, I'm going to solve by elimination. So I'm going to multiply this top equation by -5, and it's going to give me this equation that I'm writing right down here. -5n minus 5d is equal to -400. So as I add through these, my 5n minus 5n, and I apologize for not doing capital there, that just goes to 0, so those are eliminated. So I'm going to have 5d, because 10d minus 5d gives me 5d, is equal to 250, dividing by 5, I have d is equal to 50. So what does that mean? That means that d, remember d is the number of dimes, I have 50 dimes. So that's part of my answer here. Florence has 50 dimes and we're still looking for nickels, so let's plug that back into this top one. N plus 50 is equal to 80. Subtracting 50 tells me n is equal to 30. So, and 30 nickels. Word problem, word answer, right? Let's try one more. Roses sold for 12 pence each, and daffodils for 4 pence each. If Jim bought 35 flowers and spent 300 pence, how many daffodils did he buy? So R is the number of roses, D is the number of daffodils. So since we know that he got 35 flowers, we know that R, the number of roses, plus D, the number of daffodils, should equal to 35. And then we know since roses are 12 pence, the cost for each rose would be, the cost for all the roses together would be 12 times R, the number of roses. And then daffodils are 4 pence each, so it'd be 4 times the number of daffodils would be how much he spent on daffodils. And in total, he spent 300 pence. So I can solve by substitution or elimination. This time I'm going to use substitution. So I'm going to have R, just kidding. D is equal to 35 minus R. That would be my step 1. Step 2, use the other equation, 12R plus 4 times D, which is 35 minus R, is equal to 300. 12R plus 140 minus 4R is equal to 300. Combining like terms, that's going to give me 8R's plus 140 is equal to 300. Subtracting 140 gives me 8R is equal to 160. Dividing by 8 gives me R is equal to 20. And then plugging that back in over here for step 3. D is going to equal to 35 minus R, which is 20. So D is going to equal to 15. So Jim got 15 daffodils. And we actually got extra information because we found roses too, right? You got 20 roses, but it just simply asked how many daffodils did he buy. Alright, now I guess a theorem we need to talk about just real quickly here is that angle implies angle. If we're talking about similar triangles, if two angles are the same, it implies that the third angle is also be the same. And think about if we wanted to find this third angle in here. You know, it'd say 60 plus 80 plus something is going to equal to 180. Right, so that would be x is equal to 40. Right, so this angle right here is 40. And if I came down to this bigger triangle and did the same thing, 80, 60, what's this third angle? We're already doing with 80 and 60, so we're going to know that it's 40 degrees. Okay, there's kind of a little proof in the book that shows you proof of that, but it's kind of just common sense. If two angles are the same, the third one must also be the same. So let's use that to solve triangles or to find missing parts of a triangle. So notice on this one that this angle right here is the same as this angle. It's marked right there with that. And even if it hadn't been marked, we would have known that it's the same because those are vertical angles. Okay? And then it also tells us that this angle, angle B, and angle D are the same. So since two of them are the same, it would make a logical conclusion to say then that this third angle would also be the same. And if we have angle, and angle, that means these two triangles are similar. So if these two triangles are similar, let's find the sides that correspond to each other. The shortest side on the smaller triangle, ABC, it's going to correspond to the shortest side on this bigger triangle. So the shortest side here corresponds to this shortest side here. Likewise, the longest side here corresponds to the longest side here. And then the middlest side, if that's a word, here corresponds to the middlest side here. So we can do that. Let's see if we can find a scale factor to relate these two. And I'm looking at the side that has numbers on both of them. Notice this side is 3 and this side is 5. So I'm thinking 3 times what gives me 5. So if I want to solve that, 3 times something, I'll call it x, is equal to 5. So solving for that x is going to equal to 5/3. Okay? What that means is if I took that 3 and multiplied by 5/3, I would get 5. So let's do that same thing with with the sides that we're missing to find the sides that we are. So first let's solve for y. So I know 4, because that's this, times 5/3 would equal to y, which means y is equal to 20/3. And then to find x, I would say 5 times 5/3 is equal to x. So this is going to be 25/3 is equal to x. Your homework is on page 100. You're doing 1 through 15 all, and then 5 more of your choice. Good luck.